Good morning, everyone, and welcome to this presentation about tackling UI challenges in Football Manager. When I was preparing this presentation, I wasn't quite sure how many people know the game and how much you know of the game. So if you could have a show of hand, please, who's heard of FM and have a vague idea what it's like? Okay, that's probably more than I thought. How many of you played the game? How many know the mechanics and how it works and a sort of, yeah, okay, yeah. All right, I'll cover some of it, so just to give us an idea here. Before we get started, you may or may not have seen that FM 25 has been delayed by a little bit, so we normally release in early November. We'll release in late November is the plan. As a result, our public and official announce has also been delayed a little bit. It should have been early September, so by the time this talk would have happened, but it's now late September. So as a result of that, I can't really show any in-game things, so what you'll see is more generic, which is unfortunate, but it is what it is. So we'll start with some introductions. So I am Svein. I'm the Studio Technical Director at Sports Interactive. I've been at SI for a long time, since '99, when I joined as a junior programmer. And I'll hand over to Olu and Camil to present yourselves.
Yeah, everyone. Hello. My name is Camil. So I'm a software developer on the UI Tools team, and I help develop some of the features we'll be talking about today.
And my name is Olumide Olajide, and I'm a senior product designer on the UI Tools team, working on UI Toolkit to keep improving the product.
Cool. So today's presentation will consist of 3 sections. So first of all, we'll cover Football Manager, and I'll switch to using UI Toolkit. I'll start with a brief introduction of FM, what it is, and then a little bit of background of how we ended up using and choosing Unity for our game, and then show the approach that we took to building UI in Football Manager. And then I'll hand over to Camil and Olu to show the built-in data binding systems of UI Toolkit, and we'll finish off with a quick Q&A session. So first of all, a very brief introduction to FM. So the marketing speak will basically tell you FM is the most realistic in-depth football management game there is, featuring thousands of players, clubs, competitions, nations, etc. You can take control of your club and you use your thinking and management skills to just create your story and guide your club to success in the football world. That's the marketing speak. Of course, it's entirely true because I work on the game. So FM started way back in '92 as Championship Manager. Don't know if anyone of you remember that. It became Football Manager in 2004 when we released 2005, FM 2005. Don't ask me exactly why we're doing this thing where the product year is different to the actual year, because that confuses ourselves sometimes as well. FM 24 was the 20th edition of FM as Football Manager. And it will be the last where we built the game on our own tech, and FM 25 will be the first version using Unity and UI Toolkit. And the eagle-eyed of you might notice that in this stack of all the 20 editions of FM, one of them is upside down. I have no idea what that is. FM in many ways is a very different kind of game to many other games because our UI is very, very heavy. There's a lot of text on the screens. There's a lot of UI elements for presentation purposes as well as interaction purposes. And this is important for us because UI always has had to be at the focus and the forefront of what we do and how we develop our games. And so the technology behind the UI framework itself has to be very powerful for us to be able to do what we want to do. And in many ways, FM is so different from a usual game, I guess, that our requirements are more akin to what an application needs than a game normally would need. So we always like to think of it as if you can build your game using a UI framework and make our game, you can pretty much make any other game out there because ours is so complicated. Up until, as I mentioned, up until 24, we built our own, but this year we're going to switch to using Unity and UI Toolkit. And so for those of you who don't know the game mechanic, the game is essentially turn-based. So during your turn, that's when you do your stuff. You can view players, you can buy players, you can change your tactics, you can make changes to your training and all that kind of stuff. You can roam around, do whatever you want to do. The only exception to the turn-based approach is when you actually play your match. That is a real-time experience. It's still part of your turn, but the actual match is real-time. To end your turn, you click a button to end it. In our game, it's called continue. In most other turn-based games, it's usually called end turn. And that's pretty much it in terms of how the game works. Now, there were many reasons for us to think about why and how we change our game engine. One of the big goals that we had is driving some of this, and I'll touch on some of that here now. We wanted to do more frequent updates more easily than we were able to with the previous technology that we had. And we wanted to be able to do this with data-only changes, without having to rebuild the game itself when we actually send updates out to our players who get new content. So for us, it's about a lot more than just the UI itself, but because the game is so UI heavy, UI is such an important part of what we do, and when we change the game, UI changes a lot too. So in addition to that, some of the more UI-specific requirements that we have, we want to be able to create reusable UI components that are consistent across all the platforms and all the different devices that we support. Our game runs on almost anything you can think of, from phones, tablets, handhelds, consoles, laptops, and desktops. And there's a wide range of display sizes as well as input types, so keyboard, mouse, controllers, and touch inputs, obviously. Our old tech was aging quite badly and was showing its age. And one of the big things for us was a lack of tooling. It had undergone a lot of changes over the years, but it was really, really showing its age now. And if you wanted to define UI layouts, you had to do that by hand. If you hooked up or you changed data in the UI, then that usually required code changes. And although we did have a conceptual definition of separation of UI and data, we almost never really stuck to it. And all the data mechanisms that we had in the game were very often bespoke to each panel and each screen, which made it very hard to change things more on a larger scale. And also, we had no real defined UI methodology. So there was a lot of different ways of seeing things and doing things. So the consistency was lacking in the game as a result of this. And that was one of the reasons we ended up in a situation where design and our implementation was really rather disconnected. Our designers works primarily in Figma as the design tool to prototype and mock up and everything that they do. And in our old tech, our engineers had to by hand implement as best they possibly could what the mock-ups showed them to do. And the technology that we had at the time before this meant that that wasn't always possible. So you could end up quite often actually in a situation where what the designers wanted wasn't really what was possible to do. And that led to a lot of frustration, led to mistakes as well. So we took a bit of a step back. We had a look at what we had, what we wanted, and went through a process of deciding what we needed. So we had our goals and everything, and we knew what our limitations were. We wanted basically to be able to create and change UI completely data-driven, data only, without changing code, so that you don't have to rebuild the game when you do it. We wanted and needed a fully defined UI methodology from design, so that everyone is always on the same page about the UI concepts themselves, the elements, with clear definitions of what they are, what purposes they serve, and how and where to use them. And we also needed the tooling and the workflows that could enable us to do this, support us in doing it, and make sure we can actually enforce it. We also want our designers to be able to change the UI without needing any engineering support, and longer term, ideally, for them to actually create new UI. We're not quite there yet, but we are working towards that as well. And the designers, coming back to the sort of lack of consistency, what they see in their tools is what needs to come across into the game directly, mapped one-to-one. So there's no miscommunication or misunderstanding of how things are and where they are and all that kind of stuff. So we did a bit of an R&D project to look into what our options are. And obviously we ended up choosing Unity. And one of the major factors for us, because it was quite a close call, but at the time, UI Toolkit had pretty much only just been announced and was a thing in Unity. And the concepts on which that's built is basically everything that we wanted. And I'll dive into some more of the reasons behind all of this as we go along here. So, and I'll explain how, from a UI perspective, we're reaching the goals that we want to aim for. So, on a high level, we decided very early on that we didn't want to rewrite the entire game. The game is big. There's a lot of stuff in there. It's very well balanced. It does what it does extremely well. And to rewrite all of that is obviously probably another 20 years worth of work. So we didn't want to do that. We decided we wanted to keep the game world simulation in C++. But the big separation point here is the game world simulation and the UI. And the UI we have completely rebuilt using UI Toolkit in Unity. The UI talks to the game world, and there's obviously a bit of a language disconnect here. So there's a C# element to Unity, and we got a game world in C++, and they talk to each other through what we call an interop abstraction layer, which I'll come back to a little bit. And that's kind of it, really. The language barrier between the two helps us doing that completely decoupled sectioning of game logic and UI. This is what it looks like a little bit on a high level for us. I'll dive into these as I go along, each one of these, and explain a little bit how they work together and how they connect and why we ended up doing what we're doing. But essentially, we have a UI who talks to a data store. The store talks to the UI handlers, and the handlers talks to the game, and that's kind of the flow of it. So what we needed here, obviously the C++ and C#, we wanted and needed an interop layer between the two so that they can talk to each other. This boundary, obviously, as I said, provides a natural boundary to completely decouple the game logic and the UI. We created this interop layer as that mechanism. We also identified that we wanted a single point of entry for the UI to talk to the game and enforce the fact that that's the only way it can talk to the game at all. Like, there's no way to allow it to take shortcuts and sort of sneak behind the back of yourselves and talk to certain parts of the game and try to pull data from it outside of going through this layer. And that's very important. That's why we strictly enforce it. We want that separation to be completely and hardly enforced and not allow anything else to happen. So, UI Toolkit, to meet our goals and requirements, we were looking for a user interface framework that used standard modern UI concepts, inspired by and similar to web technologies like, for example, React and Redux. And UI Toolkit has UXML and USS, which is essentially equivalent to HTML and CSS. And UI Toolkit gives us a way for widgets to describe the data that they need. And they don't really care about how the data gets to them or where it comes from. That's not important. They just get data, and then they will display it to the player. And the UI will update as and when data comes across and it changes, and it only updates what it needs to update. And importantly as well, UI Toolkit allows us to extend this. So it comes with its built-in tooling. We have built additional tooling on top of that to enable and ensure the designers what they do ends up in the game with that direct one-to-one mapping that I mentioned that we really want, to make sure there's no confusion and there is the consistency. That includes some custom tooling that we've built. We've got an automated import tool that imports between Figma and into UI Toolkit and takes what's in Figma straight across. And the fact that UI Toolkit works along the same ways as web tech, which is essentially what Figma does as well, basically means that's not too hard in quote unquote. It's harder than it sounds, but it's not that difficult. So in this world where UI is completely decoupled between the game and the UI itself, we have a setup where the Widget defines what data it needs in the UXML document, and the data is requested from the data store, and the data store will either provide the data immediately if it's already available, or will go off and request it and send it back, obviously. The data store will also receive updates from the game as the game will progress, so to make sure that the UI will always reflect the latest update. And what all of this allows us to do is do prototyping and test with fake data in the editor if we want to. So we can provide a data store that either provides fake data, maybe that's quicker and just easy to do, or we can also set up a data store that actually uses the full in-game data, but without actually building and running the game and having to launch the game, load a save game, get to the right screen, and then do your work in the UI from there. You can just do it in the editor. So we built the data store ourselves, and I'll come into some of the details of why that is as well. Ours is fully observable. UI elements register their interest in the data they need by binding to data properties, and the data store requests this data, as I mentioned, from the game, and the UI get notified when the data is available. The simulation also knows what data is of interest, so that when the game progresses through time and things change, so for example, a player condition can change, go up or go down, or the transfer value can change, it'll notify the UI if this happens, so the UI will always get the updated data. And of course, multiple widgets can listen for the same data, so we don't sort of duplicate that data transfer as we go along. As I said, we did create our own data binder system. We started using UI Toolkit very early on. And at that time, we did look at the data binding system that was there, but we realized quite quickly that it wasn't as fully featured as we needed it to be. It wasn't quite ready for us to use, so we wrote our own. We couldn't really wait very long because we wanted and needed to get our prototype up and running. But more importantly, we realized that FM is a little bit different as well in the type of data that we bind to the user and how we use the data that the screens are displaying. We worked with the UI Toolkit team. We gave them our feedback, the limitation that we found, and the features and the functionality that we were looking for, which they took on board. And they have since implemented a lot of this stuff that we mentioned to them. And as a result, today, the data binding system in UI Toolkit is much, much more fully featured. However, we're still keeping our own, at least for now, because of some of those differences that I mentioned. The data binding system in UI Toolkit works by binding to data sources. Ours do as well. That's obviously what you do. In UI Toolkit, you bind to things like scriptable objects or mono behaviors. Our data come from a database of players, staff, clubs, nations, everything that's in the game. And the screen will display data of those objects. So the data sources that we have are programmatically created as a result of this, and our data binding and data request system are coupled. UI Toolkit does allow you to bind data to write code functions and do the presentations, but as I mentioned, we wanted to try to avoid having to change code. So we decided that we wanted to use visual scripting for our UI presentation completely and entirely, which allows us to do that. UI Toolkit can also bind data to property directly to styling and drive USS properties that way, which is powerful and isn't something we can do in our system, but instead we use data values in our visual scripting functions to look up style classes and apply them that way, which means that we do everything through visual functions, and our designers see in Figma what they see that ends up coming across into the game, which retains, again, that one-to-one mapping that we wanted to keep. Now, the game simulation itself only ever works on actual raw data values. It never makes any attempt at interpret the context in which this value is being displayed. It's the UI that makes that decision, so that's where the presentation logic lives. So, for example, if you have a player condition, which may be a range between 0 to 100, we can display that number itself if we want to. It might not be very exciting, but it's possible. Or we can show it as a colored health bar to imply the condition, or we can quantize it into like categories like exhausted, tired, okay, refreshed, and what have you, or any other way that we can think of. So we do all the presentation using visual scripting, and we allow absolutely no exception to this, which is how we can ensure we don't need to change code to change our UI. And for this, we've created a plugin, which is a library of our visual functions, which is a growing library of generic or generally generic and reusable functionality that obviously can be tapped into by widgets across the game. They take data as input, and they're fully data-driven, and based on the value, they decide how to present the data. We can look up the USS style class, and we can apply it to the widget. For example, if a value is 0 to 8, we're making it red, or if it's 9 to 15, we're making it white, whatever we want to do. And everything is based off of the value and everything else, and the presentation logic lives in the visual functions that we have. So all of that allows us and enables our designers to decide what data goes where and on which screen and everything else. So on a more detailed level, this is what it looks like. So if you remember the previous diagram I showed, which was similar, this is expanded out a bit so you can see how it all connects together. We have the UI talking to the store, to the C# handlers, and the C# UI handlers talks to either a C# game component or the C++ UI handler, and the C++ handler will talk to the C++ game. And that's the general flow. We do have a tiny bit of what we call game code in C#. Not a lot, but the bits that make sense lives in C#. Most of it, the vast majority, still lives in C++. Over time, we do envisage that this will change a little bit, where more stuff will probably come across to C#, but exactly what that looks like, we haven't decided. We don't really know. We're going to see what feels natural and what works for us. So this is a demo video of how this all ties together. So this is a simple panel. It's on a person. It references a person object. And we're going to add a label that shows the nationality of this person. So we've added a label, and we give it a name. And then we'll bind that data to a property on the person. In this case, is called nationality text, which is presenting the nationality as a text. And we save it, and we go into the game in the editor, and we'll refresh it, and you'll see it comes up, and we can cycle through the players and see how they all pick up the data. So now we want to add something a little bit more complicated. We're going to add a club section. We find a club section document. We're going to add that into our main document of the panel in the bottom half here. It's going to find that in the tree of widgets and stuff that we have, drag it in, and then we're going to bind that to the club name in this case by adding a binding remapper. Make sure it's parented correctly, and then we're going to set it up on the right-hand side here. We're going to map it from the club, and we're going to map it to the person's club itself, and that's of the type club. And then we're going to save it, and we're going to refresh and go back into the game in the editor, and we'll see that it's worked once it's refreshed. And again, you can cycle through them and see that. Now we want to add something a little bit interactive. So we're going to add a checkbox that allows us to hide the club details if we want to. So we're adding the checkbox in here. And then we're going to add that, make it, give it a name, show details. I'm going to make it that a Boolean, which is basically obviously true or false. And we can give that a default value. And we're going to give it a default value off, but you can change that, obviously. You can make it default on. We're going to insert an SI visible widget here afterwards. First of all, we're going to tie up that checkbox to the show details one. And now we're going to add in a visible widget, which we've created, which will contain the club details. And that is essentially what will end up showing and hiding the club details once we've connected it all up. We're connecting the visible widget to the same variable. by binding to the show details one. And that's basically it. We can save it, we refresh it, and come over to the game in the editor, and you'll see that it's now there as a checkbox. And if you tick it, it'll show it. Or if you untick it, it hides it. And again, you can cycle through the players. So finally, we want to add a little bit more data to the club section here. We want to add in the club's main team's manager name by adding a label in, and we'll bind it to the club's main team manager and show its name. And this will look up the name on the manager object of the main team in the club. Save it, refresh it, and show it here. And you can see now the manager name is shown. And this basically shows us how we can connect up the data in our UI. And design can come in, they can add new fields, they can connect up data, they can add interactions, and we can do all of this. No one's written a line of code. So it's quite powerful and allows us to do what we want to do. So that was the demos. So to wrap up my section here, I've shown that we've met our UI goals. We have completely decoupled our game logic and our UI, and we can easily enforce this. We make sure that that is and remains decoupled. We have a fully data-driven UI. We don't need to change code to make those kinds of changes. Our designers see exactly the same in the game as they see in Figma, and we need minimal engineering support to do all of this stuff. We're not quite where we want to be. We're still exploring things like, can we make it so that creating a new screen also doesn't require any code changes? So at the moment, that's the main bit where code is required and engineering support is required, because someone has to connect up the actual data object to the screen or the panel that you're on. And from there on in, you can hand it over and people can add in and drag and drop and add in all the mappings and everything. And also, can we make it so that designers can use Unity themselves and prototype and test their own changes directly in editor in Unity? We're not quite doing that at the moment. We have just started sort of the first steps towards that with getting some of our designers across into Unity. And we'll use that and see what kind of other workflow and tooling we need to build to allow us and enable us to do that. It's going to be a bit of a journey, but we're relatively confident we can get there. So that concludes my section, and I'll hand over to Camil and Olu to do the UI Toolkit data binding.
Yep, I'll take that clicker.
Yes.
Thank you.
Thank you.
So thank you, Svein, for the presentation, and thank you to Sports Interactive as well for coming out here. We think that it's super impressive that they were able to build such a great data binding system on top of the UI Toolkit foundations that we already have. The work is really impressive. It's on a slightly bigger scale than what a smaller team would be doing. So we would like to see, with all the features available in Unity 6 Preview, how could you quickly design and prototype a UI with scalability in mind using data binding? So as a reminder, you saw the builder earlier. It's our solution for our authoring editor and runtime UI, usually with a low-code approach. And we have a new data binding system in Unity 6 Preview, which is a way of displaying dynamically data from any data source that you can have in your project. It's using a path-based approach, which we'll get into during our little demo here. So speaking of the demo, we're going to be prototyping a player card for a sports game. It doesn't have to be football. And we're going to be doing this with a couple of assumptions in mind. The first one is we're going to be using as little coding as possible. We're going to try to do it in the builder using a show of hands. Who has used the builder before for UI Toolkit stuff? Okay, so a few hands. You might see some familiar workflows here and there. And also, we're going to be using scriptable objects as our data sources that are already going to be provided by a game programmer. Again, you could use any C# object as a data source, but for the sake of this demo, we'll be using scriptable objects. So here's a mock-up of what our player card looks like. As you can see, you have the player's name, an image of them. the rating, the club at the top right that they play for, and the national team on the right that they play for. You have some main stats, such as physical and technical, a bunch of secondary stats, as well as some bio details, such as the age and the date of birth. So we'll be going into the first part of the demo, which is going to be the data binding. And in the second part of the demo, Olu is going to show you some styling tricks that you could use in the UI builder as well. These parts are interchangeable, but for the sake of this demo, we'll start with the data binding. So first, we're going to take a look at our player data source, which has a bunch of the attributes that we mentioned earlier, such as first name, last name, date, and then the ratings. There's a link to 2 of the teams that they're a part of. If we look at their club here, you can see that the club has a name, a league, a country, an icon, and a list of players, which is going to be useful later on in the demo. Here's what it looks like with basic styling. Just keep in mind, this is going to be the final styling, and we use a root container here, which is going to be super useful for our data sources later on. We have a section with the ID, so essentially the first name and the last name, a section with the main stats, and the team icons, as well as a final section here with the secondary stats and the bio details. As you can see, we have a container for the ID, we have labels for the first and the last names. And then if I look here at the pattern, I have a container for the icons, for the rating, and we have another container which has a label for our stat, as well as a label for the value, which we'll bind to later on. We have, again, an icon for the country. And then we keep the same container label and label pattern here for the stats and the age here. As you can see, we use a naming convention where the visual elements describe that their names are basically showing you what's going to be in the UI and not their position itself. So what that means is it's named card container, not left container, so on and so forth. So then we're going to get into the data binding. So we need a data source and a path. Our source is going to be the team of players here, the Montreal Lumberjacks. From there, you can select part of the path. For us, let's aim at our first player in the players index, the players array. As you can see, we have an attribute override here, which shows you that the data source has been set, and then everywhere else in the hierarchy from the source, you'll see that the source is inherited. You have that little icon there that shows you that it's inherited. And that's because you use a root container at the very, very start of your UI, and you set the data source in that root container, so it passes it to every other element in the hierarchy. We can start binding, for example, the first name. We see that we already have the data source. We can simply select Add Binding, which shows you a screen with the data source, a path again, and a binding mode. So we want to bind the first name. Let's find the first name attribute. From there, you have multiple binding modes. These essentially tell you what the relationship between your UI and your data is going to be. You have two-way in which the UI and the source affect each other. But for our case, let's use to-target. What that means is that only the source is going to affect the UI and not the other way around. Once you add the binding, you have an icon there that shows you that the binding is resolved. You can see it as well in our preview. And if I take a look at the data source in the inspector here, you can see that without entering play mode, I can just change the value of the first name and it gets reflected in the UI. So again, we see that relationship where you only need to update the data source. We'll put it back to John. And then we're going to try binding other properties, UXML attributes and USS styles. So let's bind an int to a string. So change the physical value here. Again, simple. You just look at that int that represents your physical, you add it as to-target, and it gets updated here. Then we can also bind to USS styles. So let's find our player's icon. We put it as a background image, and there you have it. You can also bind to other UXML attributes, such as the value here. So we need to find the value for our strategy skill, which is in our player data source. And finally, you can also access deeper data sources within the ones that you already have. So for example, here, we're going to find our club within our player data source. And then we're going to target that club's icon to set the binding. So if you do this correctly, at the end, you'll have a very ugly but functional prototype with complete data binding. As you can see here, All of these changes are text-based and they're saved in the UXML, so that makes it much easier anytime you want to compare changes, do a diff on GitHub, so on and so forth. All right, now I'll pass it off to Olu for the styling. Thank you.
Thank you, Camil. So as a product designer, I try to separate development from design. So as you've seen, the developer has done all of the data binding. So the designer is able to step in and then start making things look fancy. So to get started, this is exactly where I left off. So to get started, there are essentially two ways to style. There's inline style and selector. But before that, what I like to first do is adjust my canvas background so I can get the reference from the artist, so that I can see exactly what I'm doing. So to do that, I select my UXML, I go to canvas background, and I can set it up there. And then what I can also do is hide some of the elements just to make it look a bit cleaner. And to do that, I just select the visual element in my hierarchy and then adjust the visibility to be none. So I'm about to style the John Maple player name using inline styles. Inline styles basically mean I can select my visual element and immediately dive into my inspector and just start tweaking and changing the values. So in this example, I'm changing the background color, I'm adding a bit of an outline, and then changing my font to make it look closer to John Maple down there. And just a little bit, and this is essentially just CSS that I'm doing, right? So that is done. We skip forward a little bit. Now let's move on to using selectors. Now, selectors work like CSS selectors. So I can declare a selector and then add properties to that selector and then use those properties to drive my visual elements. The advantage of doing this is they are reusable. So if I have multiple elements, in this example, physical 84 and technical 85, I can create a selector like I've done here. I've styled them, and then I can drag and drop them to those visual elements so that they all have the same style. So what this means is if I wanted to change the way they look, I just go back to my selector and I can use the selector to drive what all of them look like. So for example, if I have 5 buttons that they all look alike, I create a selector for button and use that to drive them. So skipping forward a little bit more, now I have everything looking a bit more fancy. So this is a unique scenario. If I wanted to test something else, say I wanted my physical to look slightly different, and then I like the way it looks, so I change the color to green, and I want to push that color to every other thing. I can select my visual element, tweak the color in the inspector, and then extract all of those styles to a selector. So now we are going to style the progress bars. The progress bars are a little bit tricky. So to target the class that the progress bars have, as you can see, the progress bar is the Unity progress bar _ progress, and then _ background. So I just need to create a selector with that exact class name. And then once I create that, it targets all of the progress bars inside of my canvas, and I can just adjust the value. And in this scenario, I'm just changing the color, and then I will also be changing the border radius. And of course, doing the same thing for the background. So the next thing I want to show is to see how variables look like. So variables are slightly above selectors, and this is also available in Unity 6 preview. So if, as you can see, the yellows I have in my scene are a bit different shade. So if I wanted to maintain a sort of consistency with that, I could create a variable with the ideal yellow color, and then go to my selector, and as you can see here, I can just right-click, add a variable, and then pick that variable. My variable is defined in my USS, and then it shows up in the builder, and I'm able to use them there. So this is our final look after all of the styling and the variables, and as you can see, all of the data binding done by the developer is still maintained. All I've done is just style the entire canvas, and I'm able to tweak all of that inside of my UI.
Oh,
and then pass it back to Camil.
Thank you. So you've styled your UI, you've bound it. Now, how can you reuse it? As I mentioned earlier, we recommend using sort of a root container to set your data source so that it's propagated everywhere else in the UI. And then that makes it also easier to just reuse all of the bindings that you've made in the past. So here, as you can see, I have a team of like 25 John Maples. I don't want 25 John Maples. So at the root of my container here, I'm going to set a data source again, but then for every instance of that player card, I'm going to use an additional index here. And then I go back in the template container and I just remove the data source that was at the root. All of the bindings are going to be preserved, and the template container is going to inherit the data source from that new UI here with the entire team. So what that means is that I was able to just remove the data source from the template container. All of the bindings within that are preserved. They're just going to be unresolved. So sort of like we can't find the data until you go back higher in your hierarchy, set the data source, it receives the data source, and that's what you get here once it's all done. So.
Okay. Thank you, Camil. So to sort of wrap up, what we've been able to show is to show you how we're able to separate styling from data binding. And like Camil said earlier, this doesn't have to be in the order of, a developer has to start data binding before a designer starts styling. A designer is able to just dive into the scene, make it all look fancy, and then a developer jumps in and then does the data binding connection to that. And then we also spoke about variables. The idea of variables, like I said earlier, is a step above selector. So just to enhance consistency, if you wanted to so I could declare a variable for color, for some numbers, so that I can then reuse them on my selector and it propagates throughout my entire canvas. So we know this is a bit much. So what we've done is, let me just step aside so you can look at this. So we have all of the assets that we showed today, the player card. So you are able to scan this QR code and you're able to see more details about what we just spoke about, and also download this asset if you want to play around with it. And then for more information about Football Manager, the QR code on the left will take you to some Football Manager materials.